Hi everybody, thank you for watching my talk. This is going to be all about parallel processing in Python, really all about the landscape of tools that exist today for parallel, distributed, cluster computing, all of those things. Things are moving really, really quickly these days. So hopefully I can at least catch you up on where we are now, but then likely this talk is going to be out of date in 6 months. So I'm not going to go super in-depth on any tool, but I'll be giving links and some resources. So if you want to grab the slides, you can kind of follow along there and click on the links. And then one thing I'll say is that all the opinions that I kind of talk about of these different tools are my own. My name is Aaron. I work for Saturn Cloud, and really my job there is to ensure that data scientists can do their work in the fastest way possible using the best tools, either the tools that they kind of already know and love, or help them along with tools that they don't yet know. And I actually gave a talk at PyData Miami in 2019. That feels like forever ago. And it's funny because that talk was actually all about how your data fits in RAM and you don't need cluster computing. So I had done a lot of work in the past with Spark, more from the data engineering side. And then I kind of always did my machine learning and data science in the PyData ecosystem, like scikit-learn and pandas and such. And I was talking all about there how you can really take advantage of your laptop, but then also do kind of parallel processing just on your single machine. And this feels like a natural kind of evolution onto ways, onto like when you actually need cluster computing, what are the right tools to choose for that job. So I work for Saturn Cloud. Full disclosure, we are a commercial offering centered around a couple of the tools that I'm going to be talking about in my talk. So I'm going to try to give like kind of an unbiased and fair shake of the stuff, but inevitably it's going to be a little bit biased, and kind of all of these kinds of talks are a little bit biased. Anyway, I'm just telling you what my bias is. So Saturn Cloud itself is an end-to-end data science and machine learning platform on the cloud. We just make it easy for data science teams and data scientists to kind of get going in Python and then get going scaling to clusters with Dask and GPUs with Rapids and things like that. So first, this is just like, why do we need parallel computing, right? We have this great, awesome PyData stack where we can do a lot of things, but a lot of these tools were historically built for single core in-memory type work. And that's really where a lot of these challenges come from. So like, if you're ready to kind of analyze your data and get going, you can use those tools fairly well. If you've seen any of my talks before, I am reusing the memes here. So apologies. It's kind of hard to find good memes these days, But anyway, you might run out of memory, right? That's the first thing. It's like, okay, well now I need a cluster. I need a bigger machine because I'm out of memory. Or if you do get enough memory, your computing just takes forever. And then you're either stuck waiting or now you have to find another solution. And then you end up feeling like this. So the entire idea is that from my talk is so that you don't feel like this and you feel empowered to choose the right tool for what you might need to do. So when would you need parallel processing? Similar to what we just went through is when you have a lot of data or you have a lot of computations that you need to run. Or both. So I do want to caveat this, and this relates a little bit to my previous PyData Miami talk, is that you shouldn't do cluster computing or parallel computing unless you have to. If everything works just fine on your laptop in Pandas, NumPy, and that kind of world, stay there. There's no reason to learn something else. If you start to if you start to kind of hit the walls of that, you can actually use most of these tools that I'm talking about today on your laptop or on a single machine. A lot less infrastructure to manage than a cluster. Same way, you can kind of bump that up to a pretty big machine in the cloud, still on a single machine. And then really when you need to take advantage of a lot of resources, you can then do a cluster on the cloud. And then you can kind of mix and match depending on specific workloads. You can do it on a cluster here or do it on a single machine there. So this is really what we're talking about, and try to say this 5 times fast. Python packages for parallel processing. I can barely even say it. But that's what we're going through today, a few different packages. I'll start with just kind of giving you an overview of the land and the world that we're kind of coming from. Again, we're starting from this kind of PyData single machine type work. These are just kind of representative packages for the types of workloads you might do. So dataframes, arrays, machine learning, and deep learning. Not an exhaustive list. But kind of in parallel, there's this other world that has been built up over the last 10, 20 years, is this kind of big data world that was really more of like data engineers, ETL type jobs. That kind of came out of the Hadoop ecosystem. So there's a few tools there. We're really not going to focus on a lot of them except for Spark. But the idea is that now that these two worlds are coalescing, where we need scientific computing, like an intense data science stuff, on large amounts of data. So we're kind of putting these two things together, and that's where some of the tools that I'm talking about fit in. We're going to focus specifically on these 3 tools, Spark, Ray, and Dask, for like the parallel computing, and I'm going to give you the stories on each of them and kind of compare and contrast. On the bottom row here, Rapids, Modin, VX, and Mars, they're kind of some honorable mentions. I'm going to talk a lot about Rapids because it's actually very relevant with these tools, but in itself, it's not technically a parallel computing tool. And then Moda and Vex, I'll mention real quick. Mars is something that's super, super new. I'm not even really going to focus on, but I at least wanted to throw the logo on there to show that there's like a lot of players in this space. But hopefully we can kind of simplify that here. So when it comes to actually choosing the tool, and really this is especially when you're choosing this for like enterprise adoption, there's a lot of considerations when you're picking an open source project, or at least things you might want to know because it'll help inform the type of experience you might get when you're using these tools. So here are all the points. I'm not going to talk about each of them because I'm going to have a slide kind of dedicated to them. But basically it's like, why was the tool created? What community was it created for? How popular is it now? How well maintained is it? How can you kind of dive into the tool itself and check out the code? And then the hardest part with a lot of this is really the deployment piece, when you have to deal with clusters and machines and infrastructure and all that stuff. And then that's where commercial offerings a lot of the times come in. They do managed services. And then I'll kind of introduce all of these tools individually for these considerations, and then I'm going to flip it and I'm going to go based on workload or capability. So I'll say dataframes, what's available, arrays, what's available, machine learning, deep learning, that kind of stuff. And it's all about what's built into the tool directly, and then what kind of ecosystem is built around the tool to enable a lot of different workloads. Because again, that helps show like how mature and how stable the tool itself is. So I took a few of these points from this talk from PyData New York City last year from Eric Dill, and he gave a great talk kind of doing something similar specifically for Spark versus Dask and Rapids. So I'm kind of pulling in Ray here, I'm pulling in some of my own opinions, and then also giving it a quick update because that talk was a year ago. So again, this space moves really fast, so it's a bit outdated now. Okay, Spark. Basically, Spark, again, was born out of the Hadoop ecosystem in that Hadoop world. It's a distributed computing platform based on the concept of MapReduce. And it was, again, created for like large-scale analytics, ETL, things that data engineers would do. And it's the oldest tool that we're talking about here. When it comes to Dask, Dask is again, distributed computing tool. These all are, but it's based on task scheduling, of low-level task scheduling. So it's a different paradigm than MapReduce, where you kind of map over a list and then kind of reduce individually. This is actually parallelizing individual units of work. And the reason this was created was specifically to scale Python code and Python packages. It was born and created at Anaconda, specifically so that so that people could accelerate Python packages. So that community that's been built up around it, you'll see the difference there. So specifically for Python. Ray is here, actually came out of the same research lab that created Spark. I think they changed names, but it's the same lab, some of the same professors and people involved. The low level of kind of task paradigm is very similar to Dask. It introduced the concept of actors, which I'll get into. But Dask and Ray, there's actually this thread on GitHub where the creators will actually talk about the differences. The main things were that actor thing, and then just some nuances of how the task scheduling works for each of these tools. But I believe that Ray was originally and initially built for like distributing deep learning applications. And I put that in a question mark only because I am the least familiar with Ray of all these tools, just letting you know, because I think the deep learning is the community I've been kind of less connected to as opposed to like data engineering, Spark, and data science with Dask and things like that. Okay, so here's a slide of just all of them so you can kind of see all the logos and see the whole story for all of them. I do need to mention one other tool, and that's Rapids, because Rapids itself, the core of what Rapids is pushing data science workloads to the GPU. So it's packages for data frames, arrays, machine learning, where now instead of executing on CPUs like all the other packages do, it'll actually execute way, way faster on a GPU. And it's really exciting. So I would definitely check out Rapids. It's a cool package. It's really mind-blowing, some of the performance speedups you get. It's newer. It's created at NVIDIA. It is an open source project, and there's a large dev team support from NVIDIA. But the key here when we're talking about parallel computing is that Rapids has a native Dask integration to actually execute on multiple GPUs, because GPUs have a lot less RAM than main memory, so you need to kind of scale out when your data gets bigger. But it integrates really well with the Python ecosystem. It's one of those consequences of Dask being Python native and built for Python. It was kind of the inevitable choice to scale Rapids. So when I'm talking about Dask, think about Rapids as kind of coming alongside with Dask as well in a lot of these places. And if you want more about Dask, another PyData talk, Keith Krause is one of the maintainers of Rapids, specifically the dataframe package, I believe. And he gave an awesome talk on just like all things Rapids. If you don't know anything about it, watch this talk. You'll be convinced that GPUs are the future, and you'll be convinced that Rapids is a great package, and Dask with it is good too. But again, it's already outdated, so there's a lot of new developments that have happened in the last year. But I'm not going to focus a lot on Rapids specifically. So when it comes to languages, I took these screenshots straight from the GitHub repos of all these projects. But the main idea here is that Spark was built in Scala. It's a JVM language. So that kind of like reflects itself in when you get errors, and that you get these kind of weird Java stack traces. And when you're trying to debug it or when you try to contribute to it, you're going to have to write in Scala. So given this is a PyData Python audience, I'm assuming that might be kind of a big hurdle for a lot of people here. Dask, you can see here, is 100% or 99.9%. I don't know what the other 0.1 is, Python. Built in Python, API for Python. Ray, its main API is Python, and it integrates with a lot of the Python packages. There is some code there kind of built in C++ and some other things, so might be a little bit more kind of hurdle to contribute if you want to. Popularity. So I don't want to look at GitHub stars, but I don't think that's the best metric. So when I think of like how popular is a person, I'll go check their Twitter or their Instagram. How many followers do they have? So maybe the same thing works for open source Python packages. I don't know. Well, so Spark here has like 30,000 followers. Again, it's the oldest tool. You see that this account was created 4 years before Dask. Dask has around 6,000 and Ray has like 1,400. So that kind of gives you some relative idea of popularity, maybe. But I have a better, more scientific metric here, which is PyPyStats. So this is pip install package. Like how many times does that happen? So it doesn't necessarily mean a net new user or a specific individual. It probably means more of automated jobs doing pip installs like daily or on some other schedule. But it still gives a good relative comparison of how popular the tool is, because if a tool is kind of being used daily for a job that's always pip installing, then it's probably being used a lot and it's probably popular. So Spark here has the most at 7 million, Dask at almost 1.5, and then Ray's there at 200,000. So this is as of October 2020, but hopefully that gives you, again, like a relative idea of the popularity. And then Spark and Dask specifically were part of the Python developer survey in 2019 that JetBrains did. And this is of all Python users. So not even just data science, like web, DevOps, like all Python users. 13% of them said they use Spark, and then 5% of them said they use Dask, which shows that there's like a big group of people actually using these tools. Like 5% of all Python users using Dask is like a good significant number. Ray wasn't on the survey, probably again because it's like newer and not as popular. Maybe it'll be in a future one. Okay, so as far as native capabilities, there's a lot here going on, but the idea is like, you know, if there's a specific thing that you do and that you focus on, or like a handful of them, this list might give you a good idea of like which tool might be the right thing to choose. So for Spark, I say the most popular capabilities of Spark are the dataframes and SQL. And then I think some people use the machine learning. I kind of recommend not to. And then Dask is all the way from like low level task parallelization. You can parallelize just like arbitrary code all the way up to data frames, arrays, and machine learning. And then Ray, you can kind of see the difference on the different kind of applications that Ray's been focused on is really a lot around deep learning, reinforcement learning, distributing deep learning training, model serving, and things like that. And then the kind of custom API is similar again to Dask, where you can do individual tasks, and then it introduced this kind of actors API. And so the native capabilities can be a little bit fuzzy because, again, when it comes to like the ecosystem, things can be built on top of these tools and built with them. And I think that's really even a more compelling type of thing to look at. So here's the ecosystem. Spark itself is mostly an all-in-one package, all-in-one tool. Partially because of the way that it was built, it's kind of internals, and partially just kind of that's how it's been. They have been doing some work to kind of pull in more PyData workloads and kind of Python support into Spark, but it does feel a little bolted on, like in user-defined functions and kind of like extraneous packages. And I think even the XGBoost had to be forked for it to work properly. So it doesn't have really a lot of ecosystem the same way that like PyData normally does with a lot of packages interacting. Dask definitely has the biggest ecosystem here because it was built specifically to support parallelization for a lot of packages. So like Rapids and scikit-learn and like a bunch of other tools. And what's especially with Dask is tools were built like specifically like where their core functionality is built with Dask, tools like Rapids and Prefect, or an Xarray, or like Dask is really, really core to how that tool works and its parallelization. Ray, you'll see here, like PyTorch, TensorFlow are big ones, again, because of the deep learning, and then like a couple other tools. It's integrations are newer. Actually, this link, if you click on it and you look at some of the GitHub pages for those integrations, some of them are just like a week or a few days old. And that kind of shows how quickly Ray is moving and like some of the new stuff that's happening right now, but it is still really new and I think not as mature of an ecosystem. Dask is listed there, and the Dask and Ray integration is specifically for using Ray's scheduler to schedule Dask tasks. That's pretty much it. I'm not sure that anybody uses that, and I'm not sure the benefits of it. I haven't been able to use that myself, so I can't really speak to it. Okay, so when it comes to deployment, like I said, this is the hardest thing generally with these tools, but the options kind of reflect again when they were born. So like Spark, Hadoop, and Yarn. Spark was born out of Hadoop, and so that's kind of one of the main deployment options. Whereas with Dask, it was built to support a lot of different workloads and a lot of like scientific and academic stuff. So there's like HPC support there, but then also like native cloud integrations where you can just put in your AWS credentials and then like run a script and then it'll launch a Dask cluster. And then Ray, again, being newer and being more cloud focused, most of their deployment options are like strictly just straight cloud. But then like, what about the pain factor, right? So it's not just like, how can you deploy, but like, how hard is it to manage and all of that stuff. With Spark, there's like a lot of more things to get working, a lot more configuration you have to do, and a lot more knobs you have to tweak. Dask is pure Python again, so that might be a little bit easier to work with. And then Ray, I don't have a lot of information to share on that because I haven't done like a whole lot of deployment with Ray, but it seems like the code that they built in there is kind of made for easy deployments. But this is where kind of commercial offerings really come to the conversation because deployment's hard. So then companies are out here giving you managed services for these tools. When it comes to Spark, there are a lot of managed services out there. Databricks is probably one of the leading ones where they kind of have like easy to manage Spark clusters. You can kind of launch them and run your Spark code. Clouds themselves also have native Hadoop and Spark offerings that I think a lot of people use. I've used EMR and Databricks both myself. And Microsoft and Google have offerings there. Dask was originally, again, born out of Anaconda. So there's a support perspective from there, but Anaconda doesn't do any like managed Dask. What's cool is that within the last year or two, there's now companies out here to do managed Dask clusters. So one of them is the company that I work for, Saturn Cloud, and Quote as well does that. Ray, the only company really in the space of Ray right now is Anyscale. I think they just opened up a private beta like a week or two ago, like really recently. And they seem to be driving forward a lot of like the Ray roadmap and all those things. But the main takeaway from this slide is that Spark is mature, has a lot of offerings. Dask is picking up a lot of traction commercially, which is a great sign, and which means that there's like there's options now and there's like support, and that like companies are really caring about it. And it feels a lot like the beginning of like the Hadoop world when companies like Cloudera and Hortonworks and such came out. And then Ray has like Anyscale kind of pushing it forward right now. But it is still like the newest. Okay, so we're going to take a quick breather here because I know I threw a lot of information at you. So hopefully you can digest some of that, look at the slides, and then we're going to pivot this now. We're going to look at capabilities and workloads, and then what tools might be the best things to choose for these different workloads. Okay, capabilities. The ones we're specifically going to focus on are these. These are really like data science and machine learning focused type workloads. And I'll talk about all of these different ones. So arrays is probably the simplest choice or the easiest kind of thing to navigate, because if you're doing multidimensional arrays and you need parallel computing for it, Dask is your choice. That's the only like definitive thing I'm going to say in this whole presentation, is that if you need multidimensional arrays, use Dask. It's really the only option out there, and it is a very good one, not just it's the only one. And then with CuPy, which is like a GPU enabled one, Dask integrates with that, so you can do like GPU accelerated arrays. With Spark, the way that it's built, it's just really not possible to do multidimensional arrays. And Ray, it's probably technically possible to like customize something with the task interface, but it's probably more work than it's worth. And so Dask is really the choice here. Dataframes is the opposite now. Dataframes is like the really, really complicated, not complicated, but really, really crowded side of the parallel computing world. We have Spark, which is its own data frame API. It doesn't mirror pandas. And then the rest of these tools are really all kind of like mirroring pandas or pandas-based APIs and things like that. So Dask has a data frame, which kind of parallelizes pandas data frames and handles the orchestration there. Koalas is a package that's a pandas front end for Spark. So all of your stuff that's happening is executing on Spark, on a Spark cluster. It's going to Scala and like all that stuff. So you need a Spark cluster and everything. But you're writing code that looks like pandas. Modin is similar, except it's for a Ray or a Dask backend. So Modin's goal is where you can just switch your import pandas to import Modin, and then it'll parallelize that to a Ray or a Dask cluster, which you kind of specify. Vax here is like an honorable mention. I have an asterisk because it's not a parallel computing tool. It's an out-of-core data frame tool. So, but people mention it a lot when they're talking about like accelerating data frames. So Vax is a way for you to analyze data sets that are larger than fit into memory on your laptop or single machine, but it's not a parallel processing tool. And then Rapids comes in for the GPU accelerated data frames, and then you can parallelize that with the native Dask integration and kind of get a lot of speed ups. Ibis here is a good thing to mention too, which is not pandas based. It's a data frame API that's more SQL kind of focused, but it's meant to have like different interchangeable backends. So like Postgres or Snowflake or anything like that, but your code is like a data frame API. So there's a lot of choices here, right? I think my kind of recommendation is that your data frame isn't necessarily the driving choice for the tool. You kind of want to think about some of the other things that you're doing, like the machine learning and scientific computing. If you're only doing data frames and you just have like a CSV that's a little bit bigger than your laptop, you have more flexibility. You can kind of choose whichever one you're more comfortable with. But you really need to think about the ecosystem and the other things that you're going to do beyond the data frames when choosing a tool. If you want to know more about this whole data frame world, though, you can check out this talk from Mark Garcia. He's a Pandas core developer in Ibis as well. He gave a great talk at a PyData meetup just recently, kind of going more in depth to this whole kind of messy data frame ecosystem. Okay, so I said that your decisions should be driven by more than just data frames. Like if you're doing arrays, you're going to want to Dask. And then we'll talk here about machine learning and deep learning specifically. So machine learning, there's more than just training a model on a giant data set. It's about like, what are you actually doing in that case? So like a lot of the times, and my last PyData talk was about this, is a lot of times you just can sample your data set and use scikit-learn, and you should do that. If you can do that and it's accurate, do that. There's no reason to like use more data when it's not necessary. So, and then if you have that trained model, when you're doing parallel computing, you're probably doing like parallel, like batch inference, or you're probably doing some sort of hyperparameter tuning or ensembling, and that's when it gets really interesting, and that's when you probably will need a lot of these tools. But there is still the concept of distributed training, like in case you really do need to use those large data sets. And so Spark has a lot of algorithms built in for distributed training. Dask and Rapids also do, and Dask and Rapids have native interoperability with scikit-learn. So you can use a scikit-learn pipeline with a Dask ML model. And that way you're not kind of having to relearn again like a new tool, whereas Spark's ML package is a completely new API that you would have to learn. When it comes to batch inference, all of these tools can really do batch inference because you're just wrapping model.predict in some sort of cluster kind of orchestration type thing. So with Dask delayed or even like a Spark UDF or something like that, you can pretty much get away with batch inference pretty easily with all of these tools. But Dask does have like a native parallel postfit class where you can like pass in your scikit-learn model, but then kind of use that same API to do like batch inference across a cluster. Hyperparameter tuning is where this gets really interesting, is when you need to train a bunch of models. Maybe the data itself is pretty small, but you need to do a lot of training. Ray, Dask, and Rapids all have offerings around hyperparameter tuning that you can kind of take a look at more. And stay tuned. I'm probably going to be working on some sort of blog post with Saturn about like specifically like which algorithms are available for distributed training versus hyperparameter tuning versus batch inference. And we'll go into a lot more details specifically on which tool has which. But as far as the distributed training, Spark and Dask and Rapids cover pretty like very similar algorithms, whereas Ray doesn't really have a lot of distributed training specifically for machine learning. Their focus is more on deep learning, like I'll show you. So actually, one thing that you'll see in all of these tools have a joblib backend. So what this means is scikit-learn has this API that uses joblib for managing like parallel training. So scikit-learn does parallel training like through a grid search or random forest, but built in it's just on a single machine. It'll use all the cores in your machine. All of these tools, Dask, Ray, and Spark, all have interfaces for a joblib backend, which will just take that training and now parallelize it across your cluster. The key here, though, is that your data has to still fit in memory of your client machine. It's not like a truly distributed training where you can kind of pull in chunks of the data automatically and then distribute from there, because you'll have to actually pull it through scikit-learn and then it gets distributed out. So this is useful for those like big compute scenarios where you kind of just need to distribute a lot of things like a random forest or like a grid search. That's kind of how you would. And here's just examples of how you might do it. It's all very similar. You just tell it a different joblib backend with the context manager. Okay, so when it comes to now tree ensembles, and this is specifically like XGBoost is mostly what I'm focusing on, and then as well LightGBM. XGBoost has ways to parallelize model training with all of these tools. Spark, it's a little clunkier. I think this XGBoost 4J Spark package, I've tried to get it working with Python. I haven't had a lot of success. Rapids as well has some stuff integrated with Spark to do XGBoost, but I think it's required some like private forks to get it working. So it's not like a super native integration. Dask itself, actually the XGBoost package, if you go to the XGBoost docs, you'll see a section about how to parallelize training with Dask specifically. So there's a really, really tight native integration there. There is a Dask LightGBM package, and we at Saturn actually, one of my colleagues there is actually working specifically on putting that natively into the LightGBM package where you can use Dask directly from there. And you can also do Dask and Rapids for the GPU computing, like shown there, which is again native to the XGBoost package. So Dask is really, really tightly coupled into that. Ray has a super new package called XGBoost Ray to do like the parallelization with Ray. Again, it's super new, so I haven't had a chance to use it, but maybe that's something to watch out for if you're interested in that. Okay, so when it comes to deep learning here, I think, again, Ray, I think was initially built for a lot of this kind of deep learning type work. So you'll see more of its high level interfaces focusing on that. So like distributed training with PyTorch and TensorFlow, hyperparameter tuning, and reinforcement learning. You can kind of check out those different libraries and see how Ray works with that. Dask, the distributed like inference is a pretty straightforward exercise with Dask. We're actually working on a blog post at Saturn to kind of illustrating that with TensorFlow or PyTorch, because you kind of just can wrap in a delayed function doing inference. And training is also possible. There aren't currently native integrations with PyTorch and TensorFlow for Dask. We are at Saturn specifically working on one. We're working on PyTorch first. So kind of, stay tuned on that. We're working on that kind of native integration. But Dask does integrate from the more of the inference and hyperparameter tuning side, not the training, with the kind of scikit-learn API packages around PyTorch and TensorFlow, so Scorch and Scikeras. If you use those tools, it's actually pretty straightforward, and there's Dask docs for how to actually parallelize across a cluster of GPUs. That's probably mostly for hyperparameter tuning or maybe inference if you're using the scikit-learn APIs with these deep learning tools. Okay, so that was a lot of stuff. So I'm hoping I at least gave you a little bit of insight onto like the different workloads and which tools might use. But then maybe you're like me. When I go to talk like this, I want somebody to just tell me what to choose. Like, just tell me which package I need to use, please. Like, there's too many choices. Well, I'm not going to completely do that. I'm just going to kind of give you some candid opinions on each of the tools, and hopefully that can kind of help you. And if you want to kind of talk about this more, find me in GatherTown or like hit me up on Twitter or something and we can chat more about this. So first, Spark. I'm just going to kind of give you my opinions. I think if you're doing stuff like already in Spark in the kind of just data engineering world of mostly SQL-esque type work and transformations, and you're not really doing a lot of machine learning, you're not doing a lot of data science specifically, Spark is probably still like a good choice for that if you're doing that, and especially if you already use it. It can be challenging with debugging Scala and cluster management and deployment. So those are still reasons that I would think even if you're only doing that stuff, you might want to consider another tool. But if you're doing like a lot of machine learning, if you're doing deep learning, scientific computing, if you have a lot of code already written in the PyData ecosystem, Spark is probably not the best choice for that, because you're going to have to rewrite a lot of your stuff. You're going to have to deal with the JVM, and probably some things that you might want to do won't even be possible. Okay, so Dask. If you don't even like want to believe me, there's a great Dask article about really like why an institution should adopt Dask and the scenarios and the reasons to do that. There's a really great article if you want to read that. Why you would use it is because of its large ecosystem of packages, because it's Python native. It's built for data science, machine learning, scientific computing. Like I mentioned, if you're doing multidimensional arrays and you need to scale them, you're going to want to use Dask. Xarray is like a fantastic and awesome package in that world. But it also has a super flexible low-level API for you to just parallelize kind of arbitrary Python code. And that's the core of what Dask is. And there's a lot of deployment options from like just Dask itself on HPC or clouds or different things. And there's commercial support for that too. Reasons that you might not use Dask, maybe if all of your work is like pure SQL type transformations, you might be better off using another tool. And then maybe not even Spark in that case. You might be better off using like a database like Snowflake or some other type of like pure SQL work. So Ray. So why Ray? I'd say Ray was built up a lot for a lot of deep learning features. So if that's all that you do and like all that you're interested in for cluster computing, Ray might be something that you would want to look at. And the low level API, like if you really want like a low level actor API, you can use Ray. Otherwise the task API again is like really similar to Dask, and Dask I think still has like a bigger ecosystem. And why would you not use Ray? I think just because it's still pretty new. Like there is a lot of momentum that like Anyscale is bringing a lot around it and a lot of stuff happening. But there's still only like one commercial player, which means that, you know, they're kind of only driving all of Ray. And so it's just like newer. And if that's something where you're kind of fine with and want to kind of like play around with it and try it, you can definitely check it out. But again, I'm a little biased. I'm probably going to recommend Dask for a lot of your workloads. So would you use more than one? That might be a question to think about when you're thinking about all these tools. I would say you're probably not going to use more than one in the same script or the same job. You could technically use more than one in the same cluster, because like if like with Yarn or something, they kind of all support Yarn maybe, but or like a cloud provider. I don't think there's really a reason to like run Dask and Spark or Dask and Ray and all those things on the same cluster. But across an enterprise, I could see potentially like an organization using more than one tool. Like if they have a lot of data engineering already built up in Spark, but they now need to parallelize a lot of their data science, they might use Dask or like deep learning stuff with Ray. Again, I think the most flexible option for like smaller teams and organizations that kind of need to do a wide variety of work is Dask. And then really, if you want to do like GPU acceleration with Rapids, Dask is really your choice, because that has really the best integration with it there. And that's it. So again, thank you for watching. I know I threw a lot of information at you. So if you want a little bit to, talk a little bit more, chat a little bit more, you have specific workloads that you're thinking about, you need to parallelize, I would love to talk with you if you find me in Gathered Town, or send me an email, find me on Twitter. We also do have a Slack community for Saturn Cloud. So you can kind of jump in there, find me, or like just post on the chat. It's, open community talking about all things Python and parallel computing and everything. And if you do want to try Saturn Cloud, if like you're really kind of convinced about Dask and Rapids, we have like a free hosted, we have a hosted product where you can get a free trial on there, and it's kind of just like a pay-as-you-go thing. You don't even have to install it in any of your clouds or anything like that. Or if you need an enterprise solution, we do have one that you can install into your kind of cloud account. But again, thank you for watching. I hope this didn't create more confusion. It might have, but hopefully at least you are now familiar with the names of the packages, what they do, what they don't do, and then that'll help drive your future research and adoption. But again, reach out if you have any questions. Thank you.